Hello and welcome to Lessons in Logic number 21. And I will swiftly arrange my Zoom controls and we'll talk about categorical syllogisms. This picture is not part of any logic lesson, but it's a nice picture. I snapped this one myself on a morning walk on Chungchao Island, south of Lantau Island, i.e. somewhere in Hong Kong. In the background, left Hong Kong Island, right Llama Island, if you can see them across the water there. In the foreground is the island of Chungchao. Okay, categorical syllogisms. I probably said at least once in this playlist that categorical logic was big for Aristotle, and it was the focus of the study of logic in the medieval era. That's why categorical logic might sometimes be referred to as classical logic. So let me say something about why categorical logic is so important, so useful. If you want to prove a conclusion, having the structure X as Y helps to find some third thing to connect the two. And it is a categorical syllogism that will make that connection through a third thing. Now, before illustrating, let's say something about the structure X is Y. This would be the structure of a conclusion. Now, X could be one thing, it could be two things. It depends on what you're talking about. Y could be one thing, it could be two things, it could be three things. It depends on what sort of Y you're talking about. Is might be phrased as R if there's more than one thing you're talking about, or if you state your conclusion in the second person or something like that. The structure X is Y is so generic that it should fit any conclusion you can come up with. And so in theory, any conclusion at all, can be drawn from the premises of the categorical syllogism. So that's one reason categorical logic is terribly important. But look how straightforward and simple the categorical syllogism is. Here's an example I like to use. Suppose Aristotle is trying to convince Alexander that Socrates was a great man. Now, you may know Socrates, the great philosopher, was the teacher of Plato. Plato was the teacher of Aristotle. Do you know who was the student of Aristotle? If you said Theophrastus, you are correct. Theophrastus was the student of Aristotle. But the more famous student of Aristotle was also someone else named Alexander the Great. So here is the sort of thing I can imagine Aristotle thinking when he's educating Alexander. He wants to convince Alexander that Socrates was a great man. So he needs an argument to persuade Alexander, and he comes up with a strategy to craft an argument. And he says to himself, Alexander knows what a great man is, and he knows who Socrates is. What I need is a way to connect the two terms, Socrates and great men. So I can tell Alexander that Socrates changed Athens for the better and that all people who do that are great men. I will use the term people who changed Athens for the better as an intermediary term to connect Socrates with greatness and thereby demonstrate my conclusion. That's how a categorical syllogism works. You have a conclusion with the extremely generalized structure X is Y, and you have to find some way of connecting X to Y, and you find a third thing to connect them. X connects to Z, which connects to Y, or something like that. Now, this is a very basic, very simple categorical syllogism. All people who are Socrates are people who changed Athens for the better. All people who changed Athens for the better are great men. Therefore, all people who are Socrates are great men. Or if you're going to state this in less formal terms, Socrates changed Athens for the better. Whoever changes Athens for the better is a great man. Therefore, Socrates is a great man. So there are any number of other forms of categorical syllogisms. Actually, there's not any other number. There's a very particular number. And have I already said this number in an earlier video? I probably did. No, I probably didn't. I think the number is 256 total. So I think there's probably 255 other forms of categorical syllogism. Don't quote me on that unless I say it later with more caution and check the math first. Anyway. A categorical syllogism, whatever its structure, will use some third thing. It always involves some X is Y, or maybe X is not Y, but that, as we know from obversion a few videos back, X is not Y also has the structure X is Y. If you change Y to not Y, in other words, X is not Y is the same thing as saying X is not Y. Or in other words, the statement guinea pigs are not mammals is equivalent to the statement guinea pigs are non-mammals. I should have said non-y at the end instead of not y. X is not y is equivalent to X is non-y. Guinea pigs are non-mammals. Guinea pigs are not, well, they are mammals. Find a simple true one. Hamsters. Guinea pigs are not hamsters is equivalent to guinea pigs are non-hamsters. Anyway, whatever is your conclusion with your categorical syllogism, there will always be some third thing to connect it. Whatever is the X, whatever is the Y, there will always be some Z that connects the two. All right, now some brief review before we, well, actually only one statement of review. A categorical proposition is a proposition which uses two terms to relate two categories. A syllogism is a deductive argument composed of two premises and a conclusion. Three statements, two premises, one conclusion. A categorical syllogism is an argument composed of three categorical propositions, two premises, one conclusion. And my notes, don't put the form of Barbara on the board. Let's not do that. Let's just type it. Here is the form of the syllogism I just gave you. In fact, I suppose I'll give you the one I just did. All M are, no, all, yes, that's right. All M are P, all S are M, so all S are P. That is the form of the Barbara syllogism. But since we're not ready yet for all this formality, let's just illustrate more concretely. Let me give you the scheme of abbreviation for the argument I was just using. And I'll orally state the argument again. All people who changed Athens for the better are great men. All people who are Socrates are people who changed Athens for the better. Therefore, all people who are Socrates are great men. Or people, no, great men was already plural. All people who changed Athens for the better are great men. All people who are Socrates are people who changed Athens for the better. So all people who are Socrates are great men. Conveniently, S stands for Socrates. P stands for great men. And M stands for people who changed Athens for the better. And now I've just given you, by typing out the form and a scheme of abbreviation, I've given you the formal version of the argument. Once again, schemes of abbreviation look like this. You use capital letters to symbolize the terms of a proposition, or if we were in statement logic, you would use capital letters to symbolize the atomic statements of an argument. Now we're just using capital letters to symbolize the terms in a proposition. And you use the same letter for a term when it appears in one statement of the argument as you do when it appears in another statement of the argument. People who changed Athens for the better occurs in both premises, and you use the same letter for each occurrence, etc., etc. Anyway, categorical syllogism is an argument composed of three categorical propositions, two premises, one conclusion, and it's got three terms. It's got the two terms of the conclusion, and then it's got that connecting term, that middle term, that intermediate term that connects, serves to connect the premise to the conclusion. So, apparently before I proceed, I have to make some sort of important announcement. Yes, this is terribly important, and I'm glad it turned up on my notes, so I didn't have to try to remember it. Until now, no matter what we did with categorical propositions, we only had two terms to worry about. Occasionally, they're term complements if we were doing obversion or something. So the normal way of using the normal way of symbolizing categorical logic when you only have two terms to worry about is to just use S and P, where S refers to the subject term and P refers to the predicate term, i.e. the first and the second term of one particular categorical proposition. Now, we are switching to a whole new system for symbolization, except it's not entirely new. Now, S and P will symbolize, as before, the subject and predicate term of a categorical proposition, but it's one proposition in particular. It's the conclusion of the syllogism, not the subject and predicate terms of just any categorical proposition. So, let me try to state this a little more formally. Whatever we did before, and however we used S and P when talking about categorical propositions, like when we had the traditional square of opposition, and we talked about how there's four generic forms of a categorical proposition: A, E, I, and O. And A is all S or P, A is all S or P, E is no S or P, I is some S or P, and O is some S or not P. And that refers to any categorical proposition you like, including all people who are Socrates or people who changed Athens for the better. That's an A-form proposition. And when we talk about it in those terms, we would use S to refer to Socrates and P to refer to people who changed Athens for the better. But we're not doing that anymore. We can't do that anymore unless that's just how it occurs. Socrates is still S. That was convenient. But M is not, but people who changed Athens for the better is not P. It's M now. Because when we're using categorical syllogisms and we're symbolizing them, we have to be much more rigid with our symbolization scheme. And you always have to use S to symbolize the subject term of the conclusion. And you always have to use P to symbolize the predicate term of the conclusion. You always have to use M to symbolize those connecting things. In other words, with what I was saying earlier, a categorical syllogism is used to establish a conclusion that has the general structure X is Y, and it finds some middle term, some Z, to connect them. X is Y, and you prove that by finding some intermediate thing that connects. On the one hand, it connects to X, Z connects to X, on the other hand, Z connects to Y. Well, now I'm telling you, when you're symbolizing an argument, a categorical syllogism specifically, when you're symbolizing a categorical syllogism, to test it for validity, that X is always S, the Y is always P, and that Z, that intermediate term, the middle term is always M. M for middle term, S for subject term of the conclusion, P for predicate term of the conclusion, not subject and predicate term, just any old proposition. Let me state it this way, which will hopefully make things a little clearer if it's not yet clear. Categorical syllogisms have two premises, one conclusion, and a total of three terms. And these terms have names. The major term is the predicate term of the conclusion. We always abbreviate it, or I shouldn't say abbreviate, I should say symbolized. We always symbolize the major term, the predicate term of the conclusion, as P. We symbolize the minor term, the subject term of the conclusion, as S. We symbolize the middle term as M. And the middle term is the one that appears once in each premise. Each term appears twice, three terms, each appearing twice. The S and P terms appear once in the conclusion, and then each of them appears once in a premise. The middle term appears never in the conclusion, but once in each premise. And that means one premise will have the major term, which is symbolized by P, and it will have M, the middle term. Another premise will have the minor term symbolized by S, and the middle term symbolized by M. So the one with S and M, since it contains the minor term, we call the minor premise, and the one with S and P, since it contains the major term, we call the major premise. And when you're putting them in standard form, you always put the major premise first. Now, speaking of standard form, a categorical syllogism is in standard form when one, all of its propositions are categorical propositions in standard form. Go back and watch an earlier video on that if there's any need. Two, its propositions are in the correct order. Major premise first, minor premise second, conclusion last. And that's it. I guess that's all we need to know to put into standard form, but a whole lot of work may go into that, particularly when it comes to putting the categorical propositions into standard form. Now, we can almost be finished with this brief introduction to categorical syllogisms, and we'll say more next time about how to put them into standard form. I think that's next on the agenda. A categorical syllogism has mood and it has figure. Figure is just the placement of the middle term. So each of these represents the different possible structures of the categorical syllogism with respect to the placement of the terms. You can have no variation in the S and P terms in the conclusion. It's always S occurring in the conclusion, P occurring in the conclusion, S first, because, well, that's how it is. The conclusion has the structure, the very general structure, X is Y, but we have to represent that more specifically as all S or P, some S or P, no S or P, or some S or not P, S being the first term of the conclusion, P being the second term of the conclusion, and it's always S first, P second, because we always symbolize it that way. We always symbolize the first term of the conclusion as S, the second term is P. And then that middle term that connects them, it could be first in the first premise or second in the first premise. And it could be first in the second premise or second in the second premise. The first premise, though, will always have P, and the second premise will always have S, because, again, that's what you do when you put the proposition into standard form. Middle term is once in each premise, major term is in the conclusion, second, and it's in the first premise, second in the conclusion, and first premise, but whether first or second doesn't matter. Well, it matters to validity, but it doesn't change whether you have it in standard form. And the minor term occurs first in the conclusion, and then it occurs once in the second premise, and it might be first or it might be second in the second premise. So there's 4 possible structures for the placement of the middle term. First, second, 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 first, first, second, no, first, second, 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 first, first, second, first. Now, for remembering which figure is 1, which is 2, which is 3, and which is 4, i.e. which of these 4 different placements of the middle term is called figure 1, which is called figure 2, which is called figure 3, and which is called figure 4. I've got very little to say that may help you. I only have this advice: memorize it. You might not have to memorize it if you're taking a logic class and you can keep a chart like this handy, or if your teacher will allow you to do the test open book, or we'll put some of this on the test, although I think that's unlikely, but it's up to your teacher. There may be no need to memorize this, but my advice is all the same, memorize it, especially if you are taking a logic class and don't just have an unusually accommodating teacher with this sort of thing. But there's one other detail I can add: memorize it, and since I think I interrupted myself, the only thing I can tell you is memorize it, and here's a mnemonic device that might help. This works for me. I really don't know if this works for everyone, but it totally works for me. Just remember these shapes. I'm making them now with my fingers. It's a little better, though, to just do it this way. I sure hope the left and rights aren't getting confused. Let's do it on the screen, but let's do it first. Let's switch to red, and then let's do it as lines, not as circles. Now, remember what we're doing this in here. We're doing this in. Let's switch that to blue, shall we? We're doing this in 4 boxes: box 1, box 2, box 3, and box 4. So in box 1, you have that horizontal line. In box 1, you have this horizontal line, top left to bottom right. In box 2, you have this vertical line, and it's a vertical line on the right, not on the left. Box 3, it's a vertical line on the left. Box 4, it's another horizontal line, but it's going up. It's from bottom left to upper right. So down going horizontal line, vertical line to the left, vertical line to the right, and then upgoing horizontal line. These 4 lines are how I remember what are the 4 figures. My advice is use this strategy unless it doesn't work for you, in which case memorize the 4 figures your own way. And that's all I can tell you about that. Mood is determined by the kind of categorical proposition of the syllogism. For example, AAA, EAO, or EIO, OIE, OOA, etc., etc. There's going to be 2 premises, 1 conclusion, 3 categorical propositions, and it could be the first one is an A proposition, an all proposition, or it could be an O proposition, a some or not proposition, or it could be a some are, or a no are proposition, an I or an E. And those same 4 possibilities are there for the second premise, and they're there for the conclusion. So now we can actually do the math. Let's do the math and figure out how many different possible categorical syllogisms are there. So the first premise could be all MRP, no MRP, some MRP, some M or not P, all PRM, no PRM, some PR, M, some P are not M. And the second premise could be all S are M, no S are M, some S are M, some S are not M, or all M are S, some M are S, no M are S, no M are not S. And the conclusion could be all S are P, no S are P, some S are P, or some S are not P. So I'm thinking there was 8 options for the first premise, 8 options for the second premise, and 4 options for the next premise. The number of different categorical propositions should be 8 times 8 times 4. Now I'm thinking 8 times 8, I'm getting 64 times 4. That's going to be 16 plus 4 times 60, 16 plus 240. So 256 is the number I expected to find. That's what I'm getting. I hope I'm not botching the math. That would be pretty ridiculous. All right, let's look at this another way. There are 4 possible figures, and then how many different moods are there? You could have 3A propositions, or you could have 3E propositions, or 3I propositions, or 3O propositions, but you'll never make any headway thinking through it that way. You could have EIO, OEI, et cetera, et cetera. How many different possible moods are there? 4 options for the first premise, 4 options for the second premise, 4 options for the third premise, and then, 4 options for the conclusion, and then 4 possible figures. So I'm getting 4 times 4 times 4 times 4. Well, no, let's not go that far, that fast. 4 possible figures. How many possible moods? 4 times 4 times 4. 4 options for the first premise, 4 options for the second premise, 4 options for the conclusion. 4 times 4 times 4, that's 16 times 4. This math is feeling awfully familiar. No, it's not quite the same equation, is it? 16 times 4. And then whatever we get, we're going to multiply that by 4. 16 times 4, I'm getting 40 plus 24. So 54. What's 54 times 4? I'm getting 200. Oh my goodness, I can't do the math out loud while recording. Hang on. Okay, this is what I'm thinking. How many different mood figure combinations are there? There's 4 possible figures. That'll be our last 4. And then there's 4 times 4 times 4 different options for the mood. 4 different options, AEIO for the first premise, 4 different options, AEIO for the second premise, 4 different options, AEIO for the conclusion. So I'm getting 16 times 4. Whatever that is, we'll make that into 4. And now this is the part I just can't do out loud while recording. There we go. I should have been able to do that in my head. I couldn't. I'm getting 16 times 4 is 64. So now our equation is 64 times 4. Is that the equation we started off with that we did earlier? 64 times 4. That's how many mood figure combinations we get. And I'm going to do the math myself one more time. 256 possible mood figure combinations. There we go. All right, is that all? That's all. That's all we have for this video. So I think our priority after this will be 1, to talk about putting categorical syllogisms into standard form. 2, to talk about the mood figure combinations. There's 256 possible mood figure combinations, and most of them are invalid. A few of them are valid, and those are the ones, well, those are the good ones, obviously. But those are the ones we'll be looking for. We want to be able to put a categorical syllogism into standard form, and then identify the mood, and identify the figure, and then see if it's one of those valid ones, and then you say whether the argument is valid, and that's it. That is a perfectly sufficient way of testing a categorical syllogism for validity. We'll work up to that, and then we'll do some other cool things, other nice ways of testing categorical syllogisms for validity. All right, thanks for watching.